Hello and welcome all to today's discussion about Apache HTTP server. Some of the key parameters which directly impact the performance of Apache HTTP server. We are going to discuss this. So some of the servers which are based on Apache HTTP server like IBM HTTP server, etc. Uh, these concepts will be applicable to those also. So we'll start with high level objective of this presentation. Then we will move to key tuning parameters of Apache HTTP server, and finally we'll wind up uh, while discussing about one of the module of Apache HTTP server, which is mod status module. So you can use that to view the runtime performance aspects of your HTTP server. Okay, so as I said, objective is just to explain some of the most important parameters which directly affect the Apache web server performance. We're going to discuss some of those parameters. Then we will see how to monitor the real-time performance of a Apache web server. So that's the agenda for today for this discussion. It's a very very crisp presentation. So hopefully it will not take much time. So now we'll move to some of the parameters. So first parameter we are going to discuss is timeout. Okay, so all these we configure in our .conf file. Okay, so I hope that's clear to everybody. So timeout is basically we use this configuration to control the amount of time the server will wait for certain events before failing a request. Okay, so if you have received a request from the client and you want to time it out after certain specified time interval, then you can use this property. Okay, so depending upon whether it's read or write happening, this variable or this configuration property can work in both the cases. So when reading data from the client, the length of time to wait for a TCP packet to arrive if the read buffer is empty. So if client is not responding, if it's slow or something, it's basically this value will cause the thread to wait until this timeout happens, and then it will give back the timeout error. And if it's writing data to the client, the length of the time to wait for an acknowledgement of a packet if the send buffer is full. Again, if for some reason there is a problem with the write happening when you are writing back the data, then this is the time interval before actually the HTTP server will report in failure. It's configured in seconds in your conf file. Okay, so this is very important to correctly set the timeout values, because otherwise if you are not specifying your values as per your application characteristics, default value may be too high for a given scenario, and you can have a scenario where lots of threads are just piling up because read is low, write is low, but your HTTP will start choking in that case. Okay, so keep alive is a second property. So keep alive when you need long sessions, long-lived HTTP sessions. Normally HTTPs, we all know, is a stateless kind of thing. Okay, so you fire a request, you get a response, that's it. Okay, but if you want long-lived sessions, so that from one client, once physical connection has been established, same connection can be used to send next request and next request kind of thing. So keep alive, you can use it. Okay, so keep alive will provide long-lived HTTP sessions which allow multiple requests to be sent over the same TCP connection. In some cases, this has been shown to result in an almost 50% speed ups in latency times. Depending upon your application characteristics, this can give you very good performance, especially with SSL, or where initial handshake is very costly. You can get very good benefits out of this property. You have to set it, keep alive true false, you have to enable it. Then in earlier version of HTTP, especially HTTP 1.0, your client also needs to tell that client wants keep alive true, so it needs to be sent in a header, HTTP header, that client this keep alive should be kept true. Only then server would keep it open for next request. Max keep alive request. So once you have configured the keep alive, you have enabled the keep alive, how many requests should be allowed in that connection, this property will determine that. Okay, so you can specify it 100, 200 depending upon your application characteristics. But if you set it 0, unlimited request will be allowed. So if you set it 0, then once the connection is established, unless someone physically close the connection, maybe because of some network error or application or server manually terminating it for some reason, it will be unlimited request if it is set to 0. Generally, higher the value, it will provide better results. Okay. So next we are going to discuss is keep alive timeout. Okay, so keep alive timeout is basically the number of seconds Apache will wait for a subsequent request before closing the connection. Okay, so if you have if client has started a keep live session, or if it has a keep live connection, so if it's not sending a request for some particular time, then you can do it a timeout by setting this value to appropriate value, keep alive timeout. Okay, setting a keep alive timeout to a high value may cause performance problems in heavily loaded servers. The higher the timeout, the more server processes will be kept occupied waiting on connections with the idle clients, right? So if you have set it too high and some of the clients are not sending request, they have just opened the connection, so your connections are getting consumed by clients which are not sending the data. So in that case you may get performance issues. Okay, moving to next property, which is start server. So this directive sets the number of threads created on the startup. So whenever your Apache web server starts, how many child processes or number of threads should be started, this variable starts this variable or this directive controls that number. Okay, as the number of threads is dynamically controlled depending upon the load, there is usually little reason to adjust this parameter. So generally we don't go and change this parameter, but this also affects your performance. So in certain scenarios you may have to look out for this. Okay, next is threads per child. So how many threads should be started or created by each of the child process which was launched at the startup, okay, or which was controlled by this start server parameter. So thread per child directive sets the number of threads created by each child process. The child creates this thread at startup and never creates more. So whenever you specify certain values, so whenever that child process is started, it will automatically start those many threads to handle the requests. Okay, so if you want child processes should be able to handle more threads, you need to configure this value. Another important parameter is thread limit. So in the last slide we have seen thread per child property or directive. So thread limit sets the upper limit on that particular directive. So once you have specified the thread limit, it will set the upper limit on the configurable number of threads per child process, that is the thread per child. Special care must be taken when using this directive. If thread limit is too high, its value is much higher than threads per child, extra unused shared memory will be allocated. Okay, so because you have set it the thread limit to a higher value, and if those are not being used, you may have scenarios where memory is allocated but it's not being used because you have allocated the threads but it's not getting used because of less load or something. If both thread limit and thread per child are set to a value higher than the system can handle, Apache may not start or system may become unstable. So it's very important that when you are configuring these values, these should not be handled too high also, because too high means you are allocating unused memory and everything, so it may cause problems in your system. Okay, max client. Max client is one of the most critical configuration which directly impacts the performance of your web server. So this variable or this directive basically tells you or your web server how many concurrent or simultaneous requests can be served by your web server. So if you have specified max client, say 100 clients will be able to directly connect to your web server at a given time, not more than that. So this is a property which directly impacts the concurrent sessions in your application. So once your client request received and max client is reached, those will be queued up. So if you have configured max client as 100 and 100 first request comes into the system, it will be queued up. Once one of the 100 request has been processed, then 100 first will be given a chance to enter into your system only. Okay. So max client is one of the most important configurations, directly impacts the maximum concurrent clients on connections. which can be established with web server. It sets the limit on number of simultaneous requests that will be served, right? We discussed about this just now. Any client request received once max client is reached will be queued up. Okay, once a child process is freed at the end of different request, the connection will then be serviced. Okay, so you have to keep an eye on this parameter very closely if you have to tune your web server. There is another parameter, server limit. So it is a upper limit on the number of processes. Okay, how many processes should be there? It's upper limit on that number. Server limit in combination with thread limits, which we discussed previously. So server limit in combination with thread limit sets the maximum configured value for max client. So if you are specifying server limit as 10 and thread limit as 10, so it means each of the 10 servers or processes in your server limit, they will have 10 threads as the max limit. So maximum threads which will be allowed to process in your web server should be 100, which is controlled by max client. So these two variables, server limit and thread limits, okay, these two will be used. These two will be used to come up with the value of max client. So if server limit is 10 and thread limit is 10, max clients will be 100. If server limit is set to a value much higher than necessary, extra unused memory will be allocated. Again, same issue with the same problem with other directives. If you are setting it too high, then you are basically allocating memory which will never be used, because there will not be that much loading on the system. So it has to be set properly. If both server limit and max clients are set to values higher than the system can handle, Apache may not start or system may become unstable. Max request per child. Okay, so max request per child sets the limit on the number of requests that an individual child server process will handle. Okay, so you have created certain number of child processes at the startup. So you can also say that during its lifetime how many requests it will handle. Once it reaches that value, it will be died out and new process will be launched. So once max request per child reached, the child process will die. If we set the max request per child to 0, the process will never expire. Okay, so generally sometime we set it, you may think that 0 is a good value, you don't want to create processes again and again. But if you have a really long running HTTP servers and that kind of things, and if you feel that there might be some memory leaks or for some reason your servers are getting hanged up or slow because of extra memory, you may try to do some experimentation with this value and try to create a new process after some time, maybe after some some requests are served, depending upon your application load, of course. So you may or may not get benefit if you are creating new processes. Your old used memory will be released and all those things. So some benefits you can see in that scenario also, if you are having some memory leaks at your web server layer and those kind of things. That's why this property is generally used. Okay, so now we'll discuss last topic of our presentation, which is live performance monitoring of HTTP server. So if you have to monitor your web server live, what exactly is going on, there is a module, status module, which you need to enable in an HTTP conf file, and then you can see certain informations in a browser. Okay, there are other methods also apart from browser, but we'll discuss about browser because that's the most commonly thing used. So status module allows to find out how well their server is performing. HTML page is presented that gives the current server statistics in an easily readable form. Okay, you can also set this to be automatically refreshed. So on a browser, open your status page, it will give you all the information at that particular time. If you want that it should be automatically refreshed, say after 10 seconds or 5 seconds, you can also do that. We'll see in next couple of slides. Okay, some of the information which is displayed: number of workers serving request, number of idle workers, total number of SSCs and byte count, time server was started, restarted, and time it has been running. Average is giving the number of requests per seconds, how much request you're getting, average to those, number of bytes up per second, and all those kind of things. Current percentage CPU used by each worker. Okay, so some of the information you will see in that page is this. So how would you enable this status report? First, make sure your status module is loaded, and you have to specify this in your conf file. Load module, by default these lines are there. It may be commented out, you need to uncomment it, otherwise you can always go and add it. Okay, you have to make sure that status module is loaded, and you have to also search on switch on extended status directive as on, because some of the information is which we discussed previously, some of the information is only available when you have extended status on. Okay, so these are the two changes you have to make. Another change you have to make is you have to add this particular set of tag in your conf file. Location, server status, some of the properties, order, deny. You can always specify IPs from where you want to allow, and those kind of things for the security purpose, but I have taken a generic example. You can always say allow from certain set of IPs, so that only those IPs will be able to access the server status page. Once you have done this and restarted your HTTP server, you can have a look at your server status by this HTTP colon your server name, whatever is the IP host name / server status. And if you want automatically refresh, simple do question mark refresh and number of seconds after which you want this information to be refreshed. Okay, these are some of the screenshots of the Apache page, status report page. So you can see current time, when it started, restart time, how long it has been running, 90 days, things, all this information, CPU usages, you can see. Okay, same way you in the same page you will see what are IPs which are connected to your server right now, PIDs, how much CPU they are taking, what requests they are giving to your server, all those things. Same way you will see individual threads or individual workers, are they reading, are they writing, are they reading request, or they just starting up, or waiting for replies, sending, are they closing connections. So you can see this information also in your uh, web server status report. Okay, so this is very useful. Generally it is used by all the web administrators, etc., to debug performance issues, or to see the health check of to do a health check of your HTTP server. Okay, so we come to the end of our discussion. Hope you liked it, and if you have any questions, any queries, just leave it in the comment section and I'll get back to you as soon as possible. Thank you very much, guys.